To know who we are, and where we're going, we must know how we arrived here. Welcome to Rephetic, a revolutionary study of the Great Pyramid, which promises to rewrite civilization's history. Welcome back, Joe Smith.
Thank you.
Thanks for watching the first two. Hopefully got through them all. Joe's going to start for his participation.
Oh, yeah. Participation award. Hold on, let me fix this a little bit.
I've made him a wallet.
Boom. Look at that. Dave, what are these three dots? I don't understand.
Those three dots are it's the company's logo.
Oh, Rephetic, huh?
Rephetic's logo.
Wow.
Represents the Orion belt stars and the pyramids on the ground.
Nice. Hey, I was joking around with them coming soon. We got to have merch. We got to have Rephetic merch.
Okay.
Yeah, it's coming soon. I'm gonna spearhead it.
Yeah. Okay. Fine.
Yeah. Let's go.
Well, you got the one piece of merch so far.
Yeah. One of a kind, truly.
So when we left off, the intro went a little long. Hour 24, and then the interior is 40 minutes, give or take. And then today we're going to go through we're going to go over the exterior and then the essentials of the build. The things that have to happen in order to produce the result. Okay.
Got it.
So a quick step back into the interior in defining this Kuhnian crisis, both the minor elements and the major elements. And I also mentioned before the part of the dating justification is this context, right? The pyramid building era, and how this masonry progression starts at Saqqara, goes to Meidum, the bent pyramid, the red pyramid, carries on to Giza. And so that's part of the evidence used to justify the context and the when also. But in that, the masonry context, when we left off with the interior, there's probably more than what I'm going to tell you right now, but these are unique elements of G1 that have no precursor, okay?
Okay.
So the idea with the masonry context is, we tried this here and then it got better over here. You see what I'm saying? So
got it.
Natural progression. These elements have no precursor. There's no context for them. They just arrive fresh and new at G1. Not at all.
Nothing
before,
predating.
Nothing before in the pyramid building era. So gabled stone, where they lean the two slabs together.
Right.
That's at the entrance. It's over the limestone chamber ceiling.
Right.
And then it's at the very uppermost, the fifth attic chamber. They do gabled stone as well. And I mentioned even the newest little secret chamber that has gabled stone in it as well. There's no precursor for gabled stone. There's no precursor for some precise axis placement in a subterranean tunneling effort. Okay? So when I mentioned the well shaft of the hewn limestone chamber on the south, close to or appears to be on the southeast axis, there's no precursor for putting tunneling on a specific, terrestrial axis, okay? The precision of the tunneling, there's no precursor for that either. A lot of very rough tunneling, okay? Like at Saqqara and other, even non-pyramid sites. Or even tunnels around Giza, There's nowhere near the precision that the northern main shaft has, okay?
Okay.
The corbelled limestone chamber. So corbelling exists in a couple other pyramids, but a corbelled chamber on a 26-degree slope, there's no precursor for that. Okay, and then the masonry shafts out the limestone chamber and out the granite chamber. There's no other shafts. They're basically 8-inch square shafts. So there's no precursor for that. And I also left out in the Orthodox assimilation attempts, they suggest that this was the Ka or the spirit of the pharaoh used the shafts to escape the structure. There's no precursor for that. It's not in alignment with everything we think we know about the Ka and the function of the Ka. Okay, just travels through walls, right? Another quick thing was the east wall niche in the Queen's chamber. There's a long tradition in tomb structure where they have an east-facing false door. So they would leave offerings on the other side of the false door. This is supposed to be, or concluded to be, where the interred would pass to and from the chamber of the pyramid. Okay?
All right.
So there are other false doors in tombs, in pyramids, et cetera, but that's not unique to G1. The slab span roof, the granite beams of the granite chamber, right? Just, and I just forgot the stupid number, but I think, again, there's more than 41 in all the attic chambers, but to span a roof with a flat slab granite block, there's no precursor for that. This is the first time they do it, so it just comes out hatched. The wearing that we mentioned in the trough, the Great Step, and the southern wall, I'm not familiar with other pyramid interior features that have anything like a wearing that we see in G1. The supposed 3-chamber burial is unique for G1 as well. Okay, and then the overall stone size, either core stones, the attic granite beams, or the casing stones. So just the average size stones at G1 and at G2 are like in the orders of magnitude bigger than all the previous other pyramids, okay? Right. So those are unique features at G1 that do not fit the context, right?
Got it.
So if our only justification was this masonry evolution context, G1 doesn't fit it. How do you explain these unique features? So again, but it's just worth noting. So I just think this discounts the masonry progression context, where it's used to justify a G1's dating and attribution. I don't think it's strong at all because these unique features don't fit that. And then we'll see some of that in the exterior as well. So anyway, that's just a little wrap up of stuff I forgot on the on the interior. And I'm sure there's others, okay? So in general, the beginning with the exterior, I call these in the book G1's absolutes. The core, brownish core limestone we know comes from the Giza Plateau. It's called the Macadam Formation, okay? The casing stones, and again, I'm going to use the word material, okay?
All right. Because
there's some question as to whether it was manufactured material or cut and quarried blocks, okay?
Right.
So I'm going to use,
yeah.
I just used the word stones twice, okay? I'm going to use the word material. So the core material is definitely constituted of Macadam Formation limestone, the Giza Plateau.
So real quick,
yeah,
because you brought up the stone, you brought up the no precursor predating the size of the stone.
Yeah.
What about, like you were just talking about, like some theories on these stones with the precision look like they could have been cut?
Right.
By
some advanced
any
technology
predating prior to
other structures. There's other structures like the Osirian Temple. There's other megalithic structures. Most of them come afterwards, but in terms of pyramid construction,
right,
the stone size at G1 is unique.
Right.
But there is some materials research that was done, but there's contention over the sampling, which we're going to get to that in the general.
Got it.
But generally speaking, again, this goes back to Petrie's survey. The base, so we're going to get into the specifics of this, and I'm going to post these slides as well in the video. But give or take 203 courses, there may be as many as 205 courses. The top few are missing anyway. The baseline, and this is key, the corner sockets. Okay, corner sockets are bedrock sockets, and I'm just giving rough dimensions here, and then we're going to get into the specifics of this, starting with the bedrock trough and the massif inclusion. But Petrie measures them 755 and a half foot, give or take, square, okay? To the bedrock sockets. Now, and we're going to get to this in a second as well. And 481 feet, I think the other day I said 485. But again, I think it could be as much as 485. Again,
45 what?
485 feet tall. The removal of the casing stones, okay, and this is, we're going to cover this also later. The removal of the casing stone is said exclusively, we're just going to strip them off there and use them to build mosques and structures in Cairo, okay? Now, you tell me, layman to this whole thing, what's easier, taking a stone from 400 feet off a pyramid or cutting a new block at the quarry?
I would say cutting a new block.
You think so?
I think.
Risking life and limb and
Right.
death to
Right.
strip off the casing stones? Now, the other thing you got to imagine is let's say closer to the top, you're taking it off. It's rolling down. You want,
Right.
do you want every stone that you desire to be broken and marred and misshapen?
Yeah.
Then you got to reshape it entirely anyway.
I would say in layman's, it sounds like the worst idea ever.
Better to quarry what you want at the quarry, right?
Right.
Okay, well, all the casing stones are stripped off. What we think we know of the dimensions, we cannot possibly know because of the removal of the casing stones, okay? The casing stones they left in, and I'm not going to start with casing stones. I'm going to start with the bedrock trough. But
All right.
the casing stones that laid intact were near the face center vertex.
Okay.
And I'm going to reference the corners and the face centers as the vertices, okay?
Okay.
But we'll get to that. Anyway, let's back up. We got the site. Around the site is basically a skirting, okay, 13-acre skirting, which is a trough.
Okay.
In the trough, we lay either sectionally or entirely paving stones, paving, let's call it material. Paving material that is up to 22 inches in size, okay,
Wow.
depth. The bottom side of the paving is irregular, okay? So conclusions are, we're going to take a misshapen and irregular bottom and quarry the bedrock so as to receive it, and then we're going to level the top of it, okay? Which is to say that if you're laying an irregular stone within a trough, you got one or two options. Some manufactured material like a limestone cement, a hydraulic cement, lay it down, set your stone in there, right?
Right.
Or the use of the well-known, well-publicized mortar. You know, we lay the mortar in there and then we're going to flatten the top, resurface the top. But indications are that the limestone or the material that is under the paving stones is this super fine limestone material that was sought after, okay? It wasn't just the run-of-the-mill mortar, okay? Again, suggestive of materials manufacturing, okay?
Okay.
Which is not the only suggestion. But the basic thing is we're gonna do this trough. Now the other challenge, I just have to get my words together for this too. The challenging part, or let's call them, we can also call them issues, okay? Issues with the build, because that fits in the Kuhnian crisis definition. Give or take, we've got the trough. At what is the southeast corner, the bedrock is lower than all of the other areas, okay? So if it's just a trough, right, all the water is going to leak out the southeast corner. So the implication is, even especially at the southeast corner, that the bedrock mass may have been greater there, okay?
Okay.
Otherwise, there's no way to level a trough or to level the paving stones within a trough, okay? The other issue is because we have a priori, meaning it was established before any research of any kind of Khufu and Fourth Dynasty, because we have this a priori conclusion or prejudice or bias rooted in Herodotus's bias. Herodotus says Khufu, here's who it belongs to. So that's really the bias. Everything after that can be called prejudiced by the bias. Any suggestion of the use of water in leveling the trough or the paving stones is by the 4th dynasty methods, which is carrying a sack of water, manually carrying water for a 13-acre leveling project, okay, for the bedrock trough and for the paving stones. Or you could do it in sections. You could do it in small sections, right? And move to the next section. So it is a possibility that you could do it manually carrying water, but the evidence seems to demand some hydrological sophistication. Okay. Anyhow, but that's all. This is all just academic. But laying the trough, leveling is a crucial aspect, right? I'm into the essentials of the build. Let me back up, and we're going to talk more about just the nature of the pyramid. So I talked about the bedrock sockets. Mm-hmm. So Petrie, in his first edition, this is the normal. It's casing on pavement on all 4 sides. Okay. In Petrie's first edition, he offers like 2 or 3 different designs for this. Okay. So what he's suggesting here is that the casing sets into the corner socket, and then the paving rests against the outside of the casing, okay? Which is entirely inconsistent with casing on pavement. Okay? So first edition, he offers 2 or 3 examples of what these corner casing stones could have looked like. Next edition, he settles on 1, okay? And I think there's a reason for it. The measurements at the face vertices are inset from the bedrock outside perimeter by about 30 inches, making it an 8-sided pyramid, okay? Or an 8-sided base. If we use the outside corner of the bedrock sockets, okay, the faces are set in by 30 inches. This makes it an 8-sided pyramid, which is sophisticated, period, by itself, okay, which doesn't fit the 4th dynasty lack of sophistication. And so through various, manifestations, people have been trying to shrink this 30-inch face inset, okay? Even if it's by 6 or 8 inches, let's shrink it up. We've got to get a 4-sided pyramid out of this 8-sided pyramid, okay? Further surveys, okay, go to great lengths to just ignore the corner sockets, okay? And just come up with their own 4-sided survey. If we include the corner sockets, as Petrie does, we got an 8-sided diamond pyramid, okay? Make sense?
Yeah, does it show on there like an aerial view?
Yes, we're going to go over that in a second.
Okay.
But the other thing about the corner casing stones to the sockets, okay, this is in my interpretation, is there's no way to know, and this is the shame of taking the casing stones off.
And the casings were what? Like
Torah limestone.
Okay.
White polished Torah limestone. There is
adhered by some sort of
set in. They had some mortar to the backing stones. And we'll talk about casings later also.
Okay. All right.
But there's contention around the casing stones and whether or not they were manufactured material, cast and poured, and then dried, because there's evidence on the pyramid itself, but the tolerance is not that of hand shaping. Okay, right. 1 block and then hand shaping the other one and putting the 2 together. Like I'm talking a 0 tolerance, no razor blade, no human hair.
Right.
Okay. So it speaks to sophistication, which we'll talk more about that later.
Got it. But smooth.
Yeah,
Smooth.
polished. Let's say
Right.
polished white, the whole thing. Let's just piggyback on this right now. In the interior, we talked about the lack of material sampling and testing, right?
Right.
Material sampling and testing that has been done on what are called the Lauer samples. So Lauer, Egyptologist, had some samples, mostly from the exterior. There was one or two from the interior. He did not test them. They got tested by Davidovitz, who was an Egyptologist also at the time, with an interest in a cement company also, yada, yada, right? But Davidovitz comes out with the Lauer samples, does some material testing, but the bonding agent between the core material indicates a manufactured material, okay? Then Davidovitz is out of the club, okay? No, for real. And what he does then is he implores the help of independent materials scientists to do the same testing. They all come up with the same answer, independent of every other one, right? One of them's Barsoom from Drexler. He's like, I didn't want to get into the pyramid thing. He just said, I was asked to do this electron microscope testing, and I did it. And here's the results. So, but I think the contention, because you're not going to argue with the materials research, okay?
Right.
It's solid. The contention then goes back to the sample custody, right? So we doubt the Lauer samples, yada, yada, yada. But as we mentioned on the interior, guess how much new sampling and testing, materials testing, has been done of the core stones and the casing stones and of the exterior?
You told me. I got this answer. 0.
Same as has been done on the inside.
Which is unbelievable.
Complete failure of those in charge of this study to execute the scientific process.
Right.
So, the nature, again, 8-sided, 485 feet tall, 203 to 205 foot courses. All the casing stone is stripped apart. The face insets, give or take, are about 30 inches from what would be the implied outside square established by the corner sockets, right? Remember I mentioned cement repair on the Great Step and the southern wall?
Yeah.
Similar cement repair on casing stones and other let's call it fuckery, okay? I mean, we're literally obscuring the nature of evidence with cement, okay? Not a good idea. And so this is all the undercurrent of this study. Okay. Here's the Orthodox study. Well, wait a second. There's issues with virtually every part of this. But most people don't get down to the nuts and bolts of the issues, right?
Right.
Let me backstep another quick thing that I want to cover is there's been a lot of people doing a lot of work on, even in the granite chamber, there's base 10 implications, mathematics, because there's 100 stones in there. Or it also contains the phi, shit. Whatever the two mathematical proportion numbers are, that the chamber is of that size.
You can edit that.
Yeah, we'll put them in at the bottom.
Yeah.
And I was amazed at how many things I got wrong in the first video.
It sounded good to me.
This date, that date, I know, but most of it, we're just pulling these dates and stuff off the top of my head.
Right.
I mean, I might read something once or twice and it's in there, but I don't have the exact date on it.
Right. It's all right.
So,
okay.
Anyway.
Anything else here?
Oh, so yes.
Okay.
Yes. So on the exterior, a lot has been made of these proportions. They may be geodetic in their reference, which is Earth commensurate, right? Like the circumference of the Earth, the polar radius, etc., with the dimensions of the pyramid.
Right. I've heard that.
Yeah. The issue with that, okay, and I'm not going to get into those areas, those two specific areas of the granite chambers, mathematical inference, or the dimensions and their geodetic inference. Okay? And the reason I'm not going to get into that is because there's no way to know the exterior dimensions. Once the casing strip, there's no way to know. So back to the corner sockets. Here's a corner socket, let's say. Petrie has the corner casing stones fit in here, and then the paving stone is up against the side. Well, you tell me, is there how many different configurations are there to put the corner casing stone so it meets the bedrock socket, okay? And then there's 22 inches of paving stone. Could you have a 2-foot flange on the outside of the casing corner, overlaying the paving stones, but still in the corner socket, like a boss on the bottom, right? You could, right?
Yeah.
Okay, so 755 and a half feet could be, 760 feet. Could be
Right.
763.
Right.
So if you had a 2-inch flange on each end, you're adding 4 feet to the whole thing.
Right.
759 and a half.
Right.
One makes just as much sense as the other. But you can't narrow the corner casing marriage to the corner socket. You can't narrow that down to one particular design.
Right.
A flange design with a boss on the bottom adds to your overall baseline length. Okay?
Right.
So as much as people try to stick with that or infer these geodetic measures or whatever, it's just it will be an unknown unless we discover the build plans, and then we can infer dimensions from the build plans, right?
Right.
That seems to be the only way.
Okay.
Okay, so the bedrock trough, give or take 22 inches of paving stones. Now,
Irregular on the bottom.
irregular on the bottom, some places, not all
Okay.
irregular, okay? And then we finish the top, and that also seems to imply some sort of mass sophisticated finishing, okay? Not just hand finishing with, a copper plate with sand abrasion,
Right.
okay? And then all the tolerances to level and things like that are in Petrie's book as well, okay? So use of water is one of those things in the trough and the paving stones, which seems required, but it's not clear as to whether it was manual or some hydrological sophistication. Okay, so the bedrock trough, we got that. Variations to the corner socket to the corner casing marriage, that's a big one. And then again, I'll put all these images up. The next quick thing, and I'll just show you this. This is Petrie's overhead diagram and the dimensions.
Okay.
This would be the existing core right now. Okay. The next one out is, as it says here, casing on pavement. And I mentioned the only ones that were there were around the face centers.
Okay.
Okay. So that's where that measurement comes from. So this is basically the depth of the casing stone, 32, 31, 35, okay? So from the core to the face centers, those are those dimensions. And then there's the implied dimensions if it went out to the corner vertices, okay? Then the additional, as you can see here, give or take 30 inches around is the difference between the face centers and the outside edge of the bedrock sockets, okay? But it doesn't have, like I said, it doesn't have to be that, give or take 30 inches. It could be 34 inches either way, right?
Right.
Adding 8 inches to the base.
Yeah.
Or 12.
This is what I don't get. So this is the structure. I mean, this is existing. This has been stripped.
This is existing. No. At the face centers, here, the casing was intact.
Just the sections, though.
Just near the face.
Right.
All the other casing was gone.
And was this existing?
Gone.
Gone. Completely gone.
Except for the sockets in the bedrock. Here. Right?
And those were how big?
the size of the sockets? No,
Yeah.
but how big is this table, really? It's just,
Really?
yeah, and a little 4 inches at an angle to receive a corner casing stone, okay? But like I'm saying, it could have been just the boss on the bottom
Right.
with a
yeah.
4-foot flange on each side.
Right.
There's
Yeah,
no
so-
way of
right.
knowing. But this outside is determined by the bedrock sockets, okay? There was no casing stone there.
And these dimensions didn't match.
Well, no, there's variance which
There's
we're gonna
yeah.
we're gonna get to that. So there is variance, particularly the southwest corner is to the east by 10 inches. It's to the north by 13 inches, out of square with the other two corners, the southeast and the northwest. Okay. The other thing important in this, if we read Petrie and it doesn't get covered much, and we're going to talk about this in a minute, is the core twist. You can see this at the top of the current core. You can see that the interior's twisted compared to what are the backing stones. Okay.
Really?
Yeah. Down at the existing core, here, for example, the northeast corner of the core is 5 inches to the west of the corner axis. So the core's twisted, particularly along the northern baseline and the corners. And at the northwest corner, it's 5 inches west of what that axis is. Okay, so this, we'll cover it later. The core twist to casing correction, okay, implies that the two maybe were completely separate processes. Okay, so here's the conventional build. We start with the bedrock trough. Here's the paving. We put the baseline. We're doing course number 1, and this we're going to get to the massif preparation, because for the first 9 courses, give or take 396 inches, 33 feet, we're building around the massif bedrock in the center. So we're not building the whole course. Okay? So the massif center is super important. But the conventional build is that we do a course. We either lay the core stone and then finish off with the casing, or we lay the casing first and we fill in the core, right? And you can do the core haphazardly. You could just fill it in and fill with mortar. As long as your casing is there and good, then it doesn't matter how you build the core, in theory, right?
Okay.
It matters when you get to the shafts and chambers. Okay, but the issue with that is, if you were doing course number 1 and your casing is perfect, but your core's twisted, that means the inside of your casing and your backing is off. Okay?
Right.
When would you correct that? After course number 1. When would you correct this core twist? Course number 2?
Yeah, that would. Right?
You might think, right?
Yeah, one would think.
Not going to happen. If you were doing the core first and then laying the casing, you would have different size stones, give or take by 5 inches, at one side versus the other side.
Okay.
The whole thing is cattywampus, to bring back an old 70s thing, right? Does that make sense?
That makes sense.
So core twist to backing and casing finishing.
Okay.
And again, nobody's suggesting that these are 2 different processes, because in the conventional way, we're building course by course from the base to the top. Okay, so all the casing, all the core stones of any given level are done basically at the same time.
Never heard about the twist.
Yeah, I know. It's in there. And again, in this whole study, like I mentioned real quick, it's like, this is not clickbait, fucking grab your attention, they got it all wrong.
Right.
But let's get into the specifics of this evidence,
Sure.
because the evidence, the known evidence, and this is also not, secret chamber, secret burial, blah, blah, blah. There's enough data and information about the nature of the structure just on its own
Right.
that tell us way more than any of those other clickbaity things. So,
Okay.
does this make sense?
Makes
Is this
sense.
so far?
So far, so good.
So far, corner sockets, corner casing, variation, right?
Yep.
Petrie's overhead diagram. By the way, the southwest corner is the highest corner, so it's
In and up.
It's It's in and up. And
Interesting.
this is the lowest and the furthest out. Okay, so it's out by a
Interesting.
foot and a half. Okay, does that make sense?
Yeah.
So where it's lower, our corner is going to continue further down.
Right.
Where it's higher, our corner is going to stop early,
Right.
except for the flange. If you could, right?
Yeah.
So this is in by this southwest corner, in by 10 inches, in by 13 inches.
Yeah, why would they do that?
Well, just I don't know. Well, the other part of this is that could also be made up with paving stone. If your normal 22 inches, maybe the paving stone here is low enough where it gives you your edge out
Right.
10 or 13 more inches.
Right.
Okay? Or maybe the paving thickness in the southeast corner is that much higher. So as your baseline, right, is rather perfect. Make sense?
Yeah.
So there's a lot of fluctuation you could do with the paving stones
Right.
and the casing corners, right?
Right.
But it's not reflected in what we're trying to look at, which
Right.
is because all the good stuff's been stripped off of it. Anyhow, so there's that. Bedrock trough, massif inclusion. Now this is the essentials of the build are surveying towards symmetry, okay, course leveling, stone mobility. Okay, those
Right.
are the big three. And we're going to talk about those. We already covered the core twist.
Yeah.
So
Interesting.
set those aside. This is
I'm
for
gonna set
later.
this aside.
This is for later.
It's for later. What are we going to dig into?
Right now, we're going to dig into the massive inclusion and surveying towards structural symmetry. And thank you for sticking around.
Yeah.
And thank you for joining me too. I know so far. And listen, at any point, if you got questions, throw them in here.
No, I've got everyone. Our brains might not function like Dave's, so I think I've got them convinced that at the end of this, we're gonna do Q&A stuff, which I think it'd be awesome to open it up to you guys as well. You know, hey,
Like a chat session,
yeah, chat
live
session, and
chat.
then do. I'm calling myself Joe Consensus here. Like, hey, average guy, don't know a whole lot, didn't you know, right?
Joe agrees.
Joe agrees. Just to say, hey, here's my questions. Here's what doesn't make sense, or here's what I'm interested to know, and then having Dave circle back with all Dave's good stuff too.
Yeah,
Right?
maybe.
That's what I want. You got to
Maybe.
give the people what they want.
Yeah, I know. Time
Otherwise-
permitting.
Time permit. That's all we got. Is time.
Right, that's
Right?
true. Okay,
Yeah.
so the massif, for those of you that know or don't know, and I'll post a picture, particularly at the northeast corner, the massif is exposed. Okay,
All right. So tell us what a massif is.
massif is the remainder of the hillock, which was supposed to have been there, rather than build entirely the first 9 courses. And let's say, give or take, if it's 20% of the volume, let's just build around the existing bedrock,
Okay.
so we don't have to take it down and then rebuild.
Okay.
So that's what the massif is. Give or take, like I said, 33 feet high, 396 inches. It receives the first 9 courses. Now, the issues with the massif are multi-dimensional, pun
Okay.
intended. Okay, so first of all, in surveying, the old kingdom, the supposed surveying methods are sighting rods, rope, right? So if you do you can do 2 same level rods, and you put one in the middle, and you can bring it in line with the other 2. Okay?
Right. Makes sense.
And surveys, rope, etc. The issue with the massif, you would think, so if this was surveyed by unsophisticated means and tools, you would expect sight lines through the massif quarried so you could do each of the axes of the pyramid. The other issue with the massif is a dead center bedrock altitude. Okay, to measure up.
Okay.
There's no indication, and I guess it's hard or perhaps nearly impossible to see if give or take at the center there's a shaft so they could do vertical measure. Maybe there is. I know what there isn't is any sight lines on all axes of the 8-sided pyramid. So we have to survey around the massif. Okay?
Okay.
To my way of thinking, and tell me in the comments if there's a way to do this, this is an impossibility. Okay? It's an impossibility to get not only a 4-sided structure symmetrical, but an 8-sided structure symmetrical around a 396-inch massif. It's also impossible to get vertical measure. Okay? It's impossible to get vertical measure unless you have, again, Pythagorean or right triangle sophistication, which we're going to explain here in a minute. How you would, again, back to the great step. So did they have vertical measure? You bet they did, because they placed the great step at exactly 141 feet. Okay? This didn't happen. Orthodoxy might suggest that a lot of this happened by accident. I'm for real. Okay? They've gotten away with that for a while.
For a minute.
Certain bits of evidence. Okay?
For a minute. It's been around.
I'm going to say my opinion, or perhaps your opinion, is, of course it's not accidental. Wait, you're going to divide the pyramid by a plane where the top is 1/3 and the bottom's 2/3? Not accidental, right? And you're going to place this enormous stone there, right? So we covered the great step, but you can't do that without vertical measure. Okay? Mm-hmm. You can't do that without the right triangle, sophisticated right triangle knowledge, and the pyramid volume formula knowledge as well. But the massif presents many, many issues. Okay? The face inset offers many, many issues. So if your face inset at the beginning is 30 inches, but by the time you get to the top, all 8 faces have come together at the pyramidion. So you have a graduated inset that gets shorter and shorter and shorter each course, right?
Right.
What's the calculus for that? If it's 30 inches at course 1 and you got 205 courses, and they're all of different thicknesses,
right? Okay,
how do you graduate that face inset so it disappears by the top?
Yeah.
Magic?
No. Highly sophisticated measure.
Yeah, or some other unknown means, right?
Yeah.
Yeah.
That's why I'm here. It doesn't make sense.
Yeah, and so there's some other implied process by which that was accomplished. And the same goes for survey, okay? Mm-hmm. And also for course leveling. I'll post the course leveling data, just to give you an example.
Okay.
By course number 7, okay, course number 7, from the northeast corner to the southwest corner, we're out of level by 5.2 inches. Okay?
Okay.
Then the next course, it's brought back to 2.3 inches. By the second course, it's brought back to 0.1/10 of an inch level. Okay?
Okay.
So we're going to go out of level over, by that point, it's probably 12 acres, right? By course number 7, we're out of level by 5 inches. And this is not just incredulity, like I don't believe that they did it, right? No, they did it. The contention is, could it be corrected by unsophisticated 4th dynasty tooling?
Right.
Okay? And could it be done at course 7 around the massif? You don't have sight lines to level along the pyramid's axes. Does that make sense?
Yeah.
So from the northeast corner to the southwest corner, we're out of level by 5 inches on course number 7.
When you say course, what are you referring to?
Just the level of stone.
Okay.
Then we're going to bring it, the next one, it's back to within 2.3. The next one, it's back to within 1/10 of an inch. We don't have sight lines through the massif. We're supposed to be doing this around the outside. It cannot be done unless I'm completely wrong. Okay? Another quick one, course number 12. So course number 9, where the massif ends, we're also 1/10 level from corner to corner. Course 10's out of level. Course 12 by 5 inches is out of level by 5 inches again. And then it's brought back within 9/10 of an inch by the next course. Okay? So these are crisis elements. That there is. And this, again, just has to do with leveling, but then symmetry, let's take, for example, the roof of the limestone chamber and the front face of the Great Step exactly on the east-west center line, okay? You can't maintain that center line through the massif, okay? Can't be done. Another quick thing, at some point, the northern main shaft is in the massif itself, okay?
Okay. So the massif is the center structure.
Center rock. It's bedrock.
Bedrock. So when you refer to massif, it's, hey, the theory now is, what does it look like when they're constructing this? What is the current theory with this massif? It's just, is it too early?
No.
So just tell me, because you're saying bedrock. Am I picturing? Am I picturing a mound of a structure?
No, it's not a structure. It's just a mound of bedrock.
Just a mound of bedrock.
We're building the courses around it and laid against it.
So like a hill.
Yes. Yeah.
Just a hill, and we're building this
around it with no sight lines.
Right. Okay.
Okay.
And it's how many acres?
13.
Good God. Yeah.
Okay, so just real quick, it's on the borderline of sorry. The other thing is, I talk about Orthodoxy demonstrating their claims, okay? No chance that anyone wants to try to demonstrate those Old Kingdom claims of leveling and doing even one course blindly around a massif over 13 acres. Okay?
Right. Okay.
So there's an issue with it. Yet it was done, obviously, right?
Right, obviously.
Okay, so there is a way to do it, which we'll get to in my hypotheses.
Right.
And spoiler alert, you know.
Yeah.
Well, no, we're not again.
That's what I want at the end of this. You gotta bring this.
Yeah, but right now we're going to talk about what we think we know now.
No, I got it. But you have
the holes in that.
You have to promise to do it.
Up. Well, we're gonna do it. What time we got?
We're at 4:35.
Okay, so
are we doing good?
Yeah, we're gonna get through all this by 5. Let's do that.
Yeah,
maybe. Okay, so I hope this is making sense so far. We have covered.
It's making sense that it doesn't make sense, right?
Well, and also the difficulty, right? The difficulty factor, and I guess really for our purpose also is Orthodoxy has the a priori when and who. Fourth Dynasty. Here's their known unsophisticated technology, right? Can that produce the evidence? That's the big question. And not only can it do that hypothetically, but can anyone demonstrate it, right? Does that make sense?
Right. So around that time, you already said the no vertical
measure.
right triangle.
Yeah. Yes. They did not have sophisticated right triangle knowledge.
And when do you know when the next structure similar to this was built?
Well, the claims are that G2 was constructed right after G1.
What about once these structures at Giza were built?
After Giza, we drop off back to the Stone Age in terms of sophistication.
Right.
Okay? With the G3 is the last major pyramid building effort. Okay? So we transition to the 5th dynasty. We end up with some diminutive pyramids and then a thing which is called the Sun Temple, which is basically an obelisk center with a structure around it. Okay? There are some pyramids built in the 5th dynasty. The beginning, a pyramid of Unas has the pyramid text, which is the first inscription of their mythology, essentially, right? The utterances of the pyramid text in the 5th dynasty pyramid of Unas. But back to unsophisticated, okay? So these are issues of building around the massif with no quarried sightlines. Like I mentioned, how do we know there's no quarried sightlines? Because the corner is exposed at the northeast corner. The corner in G2 is exposed at the northwest corner. And there's no quarried sightline through there, okay?
Okay.
So it's also, I interpret that there's no vertical shaft either, okay? Where you would get direct vertical measure for those 33 feet. Because without sight lines, you can't even, first of all, establish center, right?
Okay.
Or what that baseline would be.
Okay.
So let's say you made a vertical shaft or whatever. Or you made some sight lines like from center to center. You might be able to establish dead center baseline, right? Maybe you could. But again, there's no way to really know if that exists or not. So next. So the massif inclusion, I also, back to the interior, the northern main shaft is offset, give or take 22 feet to the east. So all of the shafts are 22 feet east of center, the north-south center. Okay. And then the chambers go to the west off of that offset. And this may have been just so you don't interfere with survey lines. That's a good reason to do an offset. But either way, so the massif presents a lot of different issues. Holding symmetry, leveling around it, okay? Holding center, vertical measure, placement of the great step we covered. The right triangle knowledge, and I guess I could touch on this briefly, is, and again, how do we know symmetry was maintained? The ceiling of the limestone chamber and the face of the great step. They're both exactly on the east-west center axis. So symmetry was maintained, right? Does that make sense?
Yeah.
Okay. So if we're going to place the great step at 141 feet, okay, you either need some other way to do vertical measurement, or you do it from your outside face. You can measure what is called the hypotenuse, and I didn't include that back when I talked in the last video,
right?
With the interior. So the c-squared measurement is the hypotenuse to the right triangle. Okay, so you can measure that hypotenuse and know how far up you are only by, let's say, your measure to center. So you need to measure from center. Let's say we're at the course where the great step is, and I just forgot the number of the course, 54, whatever it is, okay? So we're at course 54. We're holding center somehow, okay, which is still
Right.
phenomenal. And then we're going to measure from center. At course 54, we know what that, let's call it the b squared.
Okay.
So we can measure the c squared. We know what the b squared is. Therefore, we could deduce the a squared.
Okay.
So you could know how high you are. Only if you had right triangle knowledge. Okay.
Right.
The concluded builders that Orthodoxy puts forth did not. Did I say they did not have right triangle knowledge?
I've heard that.
They did not have sophisticated mathematics. They had a fundamental rise over run thing called the second. Okay, next, course leveling. We talked about course leveling, but leveling is one thing. Like I mentioned, re-leveling is another thing.
Right.
Do we change the thickness just where it's off level? Well, how do you re-level something that's off by 5 inches? Let's suppose we were doing sighting rods.
Okay.
And let's suppose you're off by 5 inches. How do you know you're off by 5 inches, first of all? Okay?
Right.
And then how do you change that leveling rod to get level on the next course? But listen, you're putting it on a course that's 5 inches out of level.
I've got nothing.
Yeah, me neither. So surveyors, if you're out there, and of course you are, weigh in on this. With the fundamental tools, I would love to see it demonstrated. So
What doesn't make sense to me
It's
though,
not-
too, but what throws me off is off 5 inches. Like I don't understand that. You're off, you're back on. You're off, you're back on.
right.
You know what I mean? Just as much as, because again, we don't know what your theories are because you're not telling us in this podcast here. You're stringing us along, but
We're just
analyzing
the evidence, yeah.
No, I don't. But if they have these tools, like, or they don't, I get it. It's easier to say, well, how did they get back on level? Well, why? I guess you're saying it's easier to say, hey, yeah, it makes sense. You don't have sophistication. You're off here. But then how are you getting back on, right? That's the greater question.
Yeah, yeah. Or how do you even do it in the first place around the massif? Right?
Well, right. We've established
we've
that.
established that. And then how do you bring a 5-inch course within the next 2 courses back to perfectly level? So anyhow, and again, it hasn't been demonstrated. Again, that demonstration thing, this doesn't rule something out, That's
Right.
That's part of the pseudoscience definition. So I'm going to exclude something as possible until you show me that it's possible.
Right.
And the reverse is true as well. So
what's the theory on that? Is there one from the Orthodox?
sighting rods and rope.
Sighting rods and rope.
That's it. Sighting rods and rope. That is the technology of the 4th dynasty. That's who built them. So we're restricted to that technology.
Right.
And so far as I'm looking at it, the unsophisticated technology, and also I would suggest any apparent technology seems like it couldn't produce this evidence around the massif without quarry lines. So
All right. Continue.
Okay, course leveling. We did all that. And re-leveling.
Yeah.
Stone mobility.
Yeah.
We also covered, write that down. Stone
Yeah.
mobility.
Yeah,
We
yeah.
covered the core twist, right?
Yeah.
Perhaps 2 separate processes. So
Talk about
Stone
mobility.
mobility. Stone mobility.
Yeah.
So
yeah.
So stone mobility. First, let's start with the heaviest stones. 70-ton pieces of granite have to come from the Nile, right? Mm-hmm. 200 feet to the base of the structure, however this is done, and then another 150 feet into the structure. Need complete stone mobility. stones all the way up to course 205 at 485 feet. We need complete stone mobility.
Yeah.
Mark Lehner himself, as everyone explores ramps, internal, external, zigzag, slope, long distance ramps, whatever, okay? Lehner himself writes, trouble at the top, okay?
Yeah.
Trouble at the top, where there's the pyramid stones and we don't have room for the ramps and for the next stone, okay? As you get towards the top, none of them make sense, okay?
Right. So what is current Orthodox?
Well,
You saying
the
ramps for real?
construction ramps. Now, there's a difference between construction ramps and quarry ramps. There's ramps in what are identified as some of the quarries, Southfield Quarry, the Central Field Quarry, okay? They have ramps in the quarry itself, okay? At the near the southwest corner, there are two small, I'm going to call them diminutive, stone walls, which suggest maybe a small ramp in between them, fill it in essentially, okay? But so in the conventional sense, course by course from the base to the top, the suggestion of ramps fits a circular argument, okay?
Okay.
Ramps must have been used, the pyramids exist. The only thing that makes the first part accurate is the accuracy of the second part. Okay? Whoop, whoop, whoop. Well, there's no evidence for ramps. Well, ramps must have been used. The pyramids exist. Well, but they're all insufficient or less than thorough. Well, ramps must have been used. The pyramids exist. It's inescapable logic of a circular argument. Okay?
Okay.
That's what we're trying to figure out. Because there's no path for a 1.5 mile ramp. The restrictions, I think, are give or take 8 degrees, okay?
Okay.
There's no path, there's no drawings, there's no remnant material, substantial remnant material, let's call it, okay? Because Lehner and they discovered stone chips, some significant quantity of stone chips in the quarry.
Barges, or no?
No.
Stone ships.
Chips.
Oh, stone chips.
Stone chips in a quarry.
In a quarry.
Do we think there's going to be a massive stone chips in a quarry? Maybe. He's saying that material constituted the construction ramps. Okay?
That's it.
That's it. The diminutive walls near the southwest corner, give or take, on the southern baseline. The only suggestion of construction ramps, okay?
Okay.
And trouble at the top, and this and that. There's literally about 800 different configurations of ramps, construction ramps, okay?
Okay.
The last one is Jean-Pierre Houdin, which is the internal ramp. Wait, there's no evidence for a ramp anywhere on the plateau, construction ramp. What if it's inside? That seems to be, let's call it the last ramp theory.
Okay.
Is that the ramp must be on the inside of the core because there's no evidence for ramps on the outside. Okay?
Okay.
And his is not substantiated.
Right.
Okay?
So any issues, are we even going to touch on it? Orthodox, how they got the stone there or not?
No,
not
I
even a
mean,
question.
no, just put them on a barge. Here's the
Right.
volume, here's the water displacement. Ship it down the Nile.
Okay.
Ship it from Aswan, where the granite came from. Ship it from Torah.
So
Like
your
said,
hypotheses and the Orthodox.
we're not talking about mine.
Yeah. Okay.
Stone mobility, unanswered. Okay? The things that make a hypotheses probable are sufficiency and thoroughness. Okay? And then also on any of these things, survey, course leveling, stone mobility, okay? The Old Kingdom methods have not been demonstrated sufficient and thorough to produce the results.
Right.
Okay?
Got it.
So of all that is said about construction ramps, nobody's putting a team of 50 out-of-work archaeologists together in Egypt and saying, manually haul this 70-ton stone up an 8-degree grade, right?
Right.
They're not willing to try to demonstrate what they claim was done. Okay?
With the level of sophistication. That
Yes, which is on a sledge. No wheel, no nothing. A sledge, maybe some timber slides spaced at intervals. Now listen, this is something most people don't think about. Let's say you're hauling 70-ton stones on a Wednesday, right? The first one goes up, they're pouring water in front of the sledge, right? The second stone, those guys have to walk on slick clay ramps,
Right.
right?
Right.
Show me.
Yeah, right.
Show me.
Right.
We're in Missouri.
Yeah. And it's Wednesday, for the record.
And it's Wednesday. Yeah,
Yeah.
yeah. So, whatever. Okay, let's
Okay,
just put it
got
in
it.
unresolved. Okay? Stone mobility is unresolved.
Okay.
Course leveling and re-leveling is unresolved. Structural survey towards symmetry around the massif, unresolved. Okay, remember back up to what I said about the parent quarries, granite we know,
Right.
macadam formation, limestone material we know,
Right.
Torah we know.
Right.
The reason I call those the absolutes, because that's really all we know
Right.
about the essentials of the build. Okay,
Where we got it. Right. Where we got it from.
that's it. Yeah.
Right. Okay.
Here's
I'm
where the
with you.
stone came from.
Right. I'm with you.
Now, also, we know that all of these things were accomplished. The symmetry, the this, the that, the survey, all of the, right? The precision's there. We know that all this stuff was accomplished. We just don't know how. And the claimed who and when and the unsophisticated processes and methods seem incapable of producing the evidence.
Yeah.
And so we mentioned the core twist. Here's another part on the core twist and construction ramps. So people don't focus or emphasize the core twist as maybe being two separate processes, because the implication is that if you build the entire core first, let's say, with your construction ramps, okay, now we got to put the casing stones on. You're going to deconstruct your construction ramps to re-expose the core face, okay, and essentially rebuild your construction ramp for phase 2, which is putting on the casing stones. Does that make sense?
No.
Okay.
I mean, it makes sense what you're saying, but it doesn't make sense.
That's what the core twist implies. Okay? Mm-hmm. So
Okay.
whatever construction ramps people do propose would interfere with casing application if indeed they're two separate processes, which it appears that they certainly suggest two separate processes. Okay, so exterior. What time we got?
We got 4:54.
All right,
We're
so
running short.
We'll get these done, and then we'll move on to the general crisis elements. So, minor crisis elements: cement repair, right? Mm-hmm. There's no real function suggested for the form. Why is it 8-sided pyramid? What's the difference between the implied inside square and the implied outside square? Okay? If there are any geodetic measures, let's say, what's the function of that? Why would somebody put those in a structure? Again, those will probably remain forever unknown. Okay? So these might be minor
What about the
crisis elements.
concrete repair? I don't get it.
It's obscuring the nature of the evidence.
Who
if-
did the concrete repair?
The
Anybody
Department
know?
of Antiquities.
Stop it.
Yeah.
Okay.
Okay. So first, we're gonna move the casing stones. We're gonna resurface them. Whatever. I don't know.
Okay. So, wow. All right.
Okay. So the
Got it.
majors, as we already talked about,
Yeah.
the massive inclusion, et cetera, et
Right.
cetera. Casing destruction is a major. Dismissal of the materials testing that has been done on the Lauer samples, okay? Mm-hmm. And the lack of duplicate sampling and testing is a major crisis element. And so the last thing, as I mentioned, as we started unique interior features, the unique exterior features, which I don't know if we mentioned all these, but the 8-sided nature, G3 also appears to be an 8-sided nature as well. Okay, so the 8-sided nature is unique to G1's exterior.
I still don't see where, if you can show me the 8-sided, because I don't.
Yeah.
Yeah.
I mean, I'll show you again.
8.
But you got them in there, don't you?
Here?
No, Oh yeah. Okay, but
show me an 8-sided.
Hold on a sec. Okay, unique 8-sided versus 4.
Okay.
There's reluctance or reticence by Orthodoxy to even address the 8-sided nature. Okay. Major crisis element. The size of the core stones, the granite stones, and the casing stones, material blocks, whatever. These are all unique as well compared to predecessors.
Right.
Okay?
We talked about that. Yeah.
So that's about it on the exterior and the essentials of the build. So here's the 8-sided nature.
Give me the 8-sided.
Just demonstrated. At the end of this whole process, there are casing blocks, materials here, okay? And here, and here.
Okay.
These are the outside of the bedrock sockets. You with me?
Okay.
This makes the 8-sided. You with me?
I'm with you.
Okay. So if you connect the center vertices to the outside bedrock sockets, you end up with 8-sided. And the face inset, here to here, around the whole thing, is I think it's a mean of like 30 inches. Okay?
Okay.
And that is crucial. Like, how does that reduction take place?
Yeah.
Okay?
Interesting stuff.
Yeah.
Hey, we got through it.
Nice. So, Great Pyramid exterior and the essentials of the construction. And I hope we didn't take any liberties. It's like, here's the evidence. Here's what seems required to produce the evidence. And then here's the Orthodox offering of the unsophisticated means and tools. Can they or can they not, by whatever method, produce that evidence? And I'm saying it seems unresolved, or completely unresolved. So even within that context, we got to look at the whole study. It's like, do we know what we're looking at? How can we have an unresolved how, and we're forcing the how into this a priori who and when and what and why.
Right.
Okay?
Got it.
So that's where the crisis comes in. And that's why we're spending this time defining the Kuhnian crisis. So anyway, we're going to move right on. Thank you. Please share, like, and subscribe. We'll see you in the next video. We're going to go through some general crisis elements and wrap up this whole 4-part Orthodox critique.
Yeah, more to come.
Thanks, Joe.
Yeah, chime in. Q&A. Dave's theories. Yeah, Dave's corner. I don't know what we're going to call it. But
we'll call it something.
We got to do it.
Joe agrees. Talk to Joe. Talk to Joe.
Yeah.
Right.
I love it.
All
right, buddy.
See you.
See you guys.
To know who we are, and where we're going, we must know how we arrived here. Welcome to Rephetic, a revolutionary study of the Great Pyramid, which promises to rewrite civilization's history